welcome to CEC lectures. Myself Dr. Preeti Jagwani. I am Associate Professor, Department of Computer Science, Aryabhat College, University of Delhi. So, in our previous lecture, we started with a new series which is Advanced Data Structures and Algorithms, and in that lecture, we started with the topic of escape list, and we understood what is escape list. So, let me give you a quick recap of the introduction of the escape list and its kind of implementation level details. And in today's lecture we are going to kind of begin with, or we are going to cover the operations which are search, insertion and deletion in case of the escape list. So, escape list basically is a list which is kind of covered in the form of I can say, or which is implemented in the form of different levels, where h represents the height of the escape list. And just to give you a quick recall, the escape list structure is available on the screen. So, here we have the levels starting from S0 to S4, and your S0 is having all the elements of the escape list which are in the sorted order. S1 is having almost half of the elements of the elements which are available at S0, and S2 is having half of the elements which are available at S1, and that is why this is named as escape list, because every level which is above is going to skip some elements which are available at the lower levels, and your S0 is having all the elements, and that too in a sorted order. So, this is basically the concept of escape list which we have covered in our previous lecture, and we have also seen that how to implement this escape list, and we understood that for implementation we need to have positional abstractions. Positional abstractions as in we need to maintain after P, before P, then below P and above P. All these positional abstractions are to be maintained, and those positional abstractions will be required while implementing the node structure. What is going to be, or what could be the node structure? So, node here in case of escape list will be implemented as a chord node which is having an element and the I can say pointers in all the directions. So, this is what kind of we have covered in our previous lecture, escape list and some implementation level details. Now, let us begin with kind of searching the searching of the elements, how to search the elements. Now, it is very simple. So, for example, we start from the minus infinity thing. So, that means we start from the leftmost, and then we will, with the help of after P abstraction, we will go to the next element, and the element which we want to search we will compare here with the element. So, for example, we need to search for 78. So, first we will compare it with minus infinity. The element is element which we are looking for. Our key is greater than minus infinity. So, our search will go ahead in the right direction by going into after minus infinity, which is 31, and then 31 will be compared with 78. Still we need to go forward because 31 is less than this. So, we need to go down. Then we compare with after of 31, which is 34. We still need to go on the right side, which is 64. Again, after of 64 is plus infinity, and we have not reached the last level. So, we will go down, which is 60, coming down from 64, and then the after pointer or after positional abstraction of 64 will give you the successful result of your search, which is the element which you are looking for is the 78. So, for example, what are we going to do is we will start from minus infinity, come down, then keep on scanning in the forward manner till you get the element which is greater than the key. So, moment you get the element greater than the key and you have levels, at levels at the lower on the lower side, then you will go down, again scan forward till the point you have the elements less than the key, and then you keep on coming down and going forward. So, what is going to be the algorithm in this case is, let us say we want to search for a key X in a skip list. So, we will be starting at the first position of the top list, and at the current position P we will be compare X with the key Y, which is the key after P. So, here in this example here minus infinity, let us say we are talking about level S2 and minus infinity is your P. So, we will be looking into the key which is available after minus infinity, which is nothing but 31. So, this is the way we start at the first position of the top list, which is minus infinity, and at the current position P we will be comparing X with Y, X with Y, which is the key after P. And if it is X equals to Y, so for example, if we are looking for 31, then we have our element which is found at S2, and then we can kind of report it. How to report it? Because it is having elements replicated at the lower levels also, that we will see. But if it is the element which we are looking for, we can report it directly. If X is greater than Y, then we need to scan forward. That means all the elements as they are stored in the sorted order are stored, the elements which are less than key are stored on the will be stored on the left side of the key. So, if X is greater than Y, then we need to scan forward. That means the element which we are looking for or our key is X, and which is greater than the key Y, which is at the after position of the current pointer. And if your X is less than Y, we need to drop down, and if we try to drop down past the bottom list, we will return no such key. Now, what does it mean? So, for example, let us say I am looking for a key which is 60 here. So, what will happen? I will start from minus infinity. The after key of minus infinity is plus infinity, so I will go down, the levels are available. Then here now after key of minus infinity is 31, I will compare 31 with 60. So, 60 is greater than, so I will come down here and then look forward, then I'll look forward. So, I'll look forward, the next element is 34, again there is a scope when 34 compared with 60, I'll try to compare it with 64. Now, if it is 64, then I'll come down, I'll not go to the 64 in case of 60, I'll come down, and after 34 the next element is 44, still 60 is greater than. So, the next element is 56, is still the key I am looking for is greater than, and the next element is 64. So, then in this situation I will say that I have surpassed the kind of the order or the place of the key on which the key should have been placed, provided it is available inside the skip list. What I am trying to say here is, in between 56 and 64 there should be key 60. But if you are through your pointer movement you are coming to 64 and you are not finding the key 60, that means that key 60 is not available, because now from here we can't even go drop down, that is the last last level. So, that is what the last statement is saying here. If we try to drop down past the bottom list, we return no such key is available. So, the search here could be a successful search or it could be a kind of an unsuccessful search. So, both these kind of results should be return. So, for example, 64, as I have told you, is going to return in a successful search, and it will list the node Si, it will list the pair, or it will give you the pair which is Si and the node visited, and also the return value which is available 64. For example, we are looking for 27, or in the previous example I have to example I have taken 60. So, if I am looking for search 60, or if I am looking for search 27, we will be listing the node pairs visited and the return value. Return value here in this case will be no search key. So, your search can be a successful search, or it can be an unsuccessful search. Now, that's kind of a very general concept. Now, apart from search, we have other algorithms which are important, which we can say is your update algorithms. For example, your update algorithm has your insertion and deletion. Now, in the first lecture we talked about that your skip list is actually a probabilistic data structure. Now, what is this probabilistic data structure? So, probabilistic data structure says that a randomized algorithm, or some kind of randomization is being used in order to maintain, or in order to control the data structure. So, that kind of data structure which is being controlled or maintained with the help of randomization is known as a probabilistic data structure, and so is your skip list. It is a probabilistic data structure. What kind of randomized algorithm it is going to use, that comes that introduces here the topic of insertion. So, this randomization algorithm is required when we try to insert a particular value inside or in the list skip list. So, a randomized algorithm performs coin tosses to control its execution. So, here in the case of insertion in skip list, we will be using a coin flipping algorithm in order to control the number of levels, or in order to determine that whether an element which is being inserted will be replicated on the next level, yes or no. This kind of situation is being determined with the help of your a randomized algorithm. So, randomized algorithm will have some statements of the type, for example, B is a value which is coming from a random function, I can say. So, if B is equals to 0, you need to do something, or if B is equals to 1, you need to do something else. And also the running time of this kind of randomized algorithm depends on the outcomes of the coin tosses. So, what does it mean? So, for example, I am going to insert a particular element at level 0, because the first level on which you are going to replicate, or on which you are going to insert an element or insert a new element, is going to be level 0. So, on level 0 I have kind of inserted it. Now, the question comes up in case of skip list, whether I should replicate it on the next level or on the level above the S0. That depends on whether my coin flipping algorithm, or whether my coin flipping function is going to give me a head. If it is a head, I will replicate the element on the level 1, again I will flip a coin. If it is head, I will replicate the element on S2 as well, and I will keep on doing, or I will keep on replicating the elements on the level above it, is basically dependent on the number of heads, or the kind of outcomes of the coin tosses. So, till the time I am going to get heads, I will replicate it. The moment I am going to get a tail, I will not replicate it. So, this kind of randomization algorithm or randomized algorithm is going to be used in case of insertion. But and because of this randomized algorithm, we say that the running time is actually the expected running time, and we normally analyze the expected running time of a randomized algorithm under some assumptions. What are those assumptions? The assumption number 1 says the coins are unbiased. The assumption number 2 says the coin tosses are independent. So, we have an unbiased coin, and the outcome of one particular coin toss is not going to is not going to affect the next coin toss. And the worst case running time of a randomized algorithm is often large but has a very low probability. So, for example, it occurs when all the coin tosses give heads, or even all the coin tosses are going to give you tails. That means you are not going to replicate your elements at all. So, this kind of situation is having a very low probability. So, running time, as I have told you, is the worst case running time could be potentially very bad, but that worst case running time will occur with a very low probability, and this is the I can say characteristics of the randomized algorithm. So, now what are we going to do here is, let us say we want to insert an item on a particular level, and the item is, let us say x, and we want to insert with it with 2 levels, which is, let us say I is equals to 2. So, if I is less than h, which is already existing list, we are going to add the new skip list or new level onto the list, and we will be adding sh plus 1 to si plus 1. Each level will contain only the 2 special keys, as I have told you, minus infinity and plus infinity. So, for example, I am looking for I is equals to 3, that means the element or maybe I is equals to 5, that means the new element which I am going to insert should be replicated at 5 levels, and the already which are the number of levels which are already present in a skip list are nothing but 3. So, that means we need to increase the number of levels. So, while increasing the number of levels, we will be adding new skip list onto the existing new list onto the existing skip list, each containing only the 2 special keys. And now, insertion, when we talk about, please try to comprehend that this insertion will insertion will require, or even deletion also will require, the key to be searched first, or I can say the position of the key to be searched first. And how it is to be searched, that we have seen in the search algorithm. So, we search for x in the skip list and find the positions P0, P1, Pi. These are the position of the items with the largest key less than x in each of the list, and with j is equals to 0 to I, we will insert item x onto the Sj after position Pj. So, this is basically, I can say, is an standard algorithm of your insertion in a skip list, in which we are looking for number of level first if we want to replicate a particular element till so and so levels. Then we will look for the position of the largest key less than the key you want to insert. So, for example, there are 2 keys 57 and 63, and you are looking for 60 to be inserted. So, 63 is the largest key less than 60. So, we will look for that position, that means before 63 we are going to insert 60, that position is to be looked out, that position is to be searched, and with that we need to insert our element into the list. So, for example, I am going to take an example here in which I am going to insert a key 15 with I is equals to 2, and as you can see I is equals to 2 is not available here. That means the existing height of the skip list is not sufficient here. here. So, I will start from the left node going down, and then we have kind of 23 there, then we need to go down again, and then we have 10 here. So, 23 is the key, largest key, which is less than 15. So, that means we need not to go till 23, we will stop before it, we will come down, and after coming down going in forward direction, I have got 10, and then there is 23. So, this is the place that is after 10 and before 23, that is the right place for the key 15 to be inserted, because I was looking for the largest key less than 15, which is 23, and I have by going in the down direction, I have come to the lowest level, which is S0, as you can see in the figure, and then I will be inserting 15 after 10. So, that 15 is actually inserted here. Now, but the point is 15 is inserted, and I have already given you I is equals to 2. So, that means on 2 more levels I will be replicating I. So, this is which is 50, I will be on 2 more levels I will be replicating my key, which is 15. So, on in the figure which is given on the right hand side, you can see your 15 is replicated on S1 and your 15 is replicated on S2, and because of this action, one more list is being introduced in the skip list, which is at the level S3, starting from minus infinity to plus infinity, because the last level will have only the 2 elements minus infinity and plus infinity, and that we have seen earlier also. So, this is the way in which we are going to kind of insert the keys, and please comprehend that you need to incorporate the searching algorithm first. Look for the particular position where element has to be searched, and then only you will be kind of inserting the elements. If I is being given as fixed, as in the previous example I is equals to 2, that means on 2 more levels you will be replicating it. Or I can say this I could be number of heads, number of heads which are coming continuous. So, for example, the situation is I am going to insert 15, okay, I will flip a coin and it is coming head, I is equals to 1, again I am flipping a coin, it is coming head, I is equals to 2, and now I am flipping a coin, it is coming as tail. So, that means the last value of I is equals to 2. So, that value is being actually is actually being determined with the help of a we can say randomized algorithm. Similarly, this was the this was the case of insertion. Similarly, if we talk about deletion, in order to remove an item, let us say the key of the item is X and we want to remove that from the skip list, we need to search first for that S in the skip list, and we need to reach that particular position of the skip list, and we will be removing all the positions. That means the whole tower corresponding to that particular X is to be removed. That is why we say that we remove the positions P0, P1 till Pi from the list S0, S1 till Si. So, let us say you need to kind of delete 23, or maybe let us say let us take the example of one particular element, let us say 64 and 34. That 34 is kind of replicated on 2 levels, which are P0 and P1. So, from the list S1 and S2, we need to remove that 34. So, that means that whole tower corresponding to that key which we want to delete has to be deleted completely. If we talk about deletion, and we remove all but one list containing only the 2 special keys. So, here is an kind of figure in which the process of deletion or removal of key which is 34 is being given. So, from minus infinity we started. So, first search is going to take place, then this is going to the after position of minus infinity at level S3 is going to give you 34, which is the key which you are looking for, but now you need to look, you need to remove the whole tower. So 34 from S2, then 34 from S1, and then 34 obviously from S0 has to be deleted. So we need to delete that key from all of the levels, and which you can see the next which you can see in the right side figure. The right side version of this skip list is actually completely free from 34. One more thing which you need to notice here is the decrease in levels. So the decrease in levels is the early before removal of 34 there were total 4 levels including S0. Now 34 is the only element on the second last level from or the top second top level. So in after 34 now your S3 and S2 both are having only 2 elements, 2 special elements, minus infinity and plus infinity. That means there is no need to kind of keep S3 as well as S2 as well as S3 both the things. So that's way that is the way in which we are going to kind of delete the elements, and all these insertion at least is going to be with the help of randomized algorithm. And what is the kind of, I can say, the bone of contention which is going on in the mind of a user is the space usage, because we are in a way kind of replicating. So the space used by a skip list actually depends on the random bits which are used by each invocation of the insertion algorithm. So let us say we have a skip list with n items. So we will insert an item in the list Si with a probability 1 by 2i, and these are the claims which we have which we can understand with the help of a binary search tree and having its log n level. So and the expected size of list Si is n by 2 to the power I, and the expected number of nodes used by the skip list is also given in the form of an expression on the screen, because the two probabilistic facts, the first one says the probability of getting I in the consecutive heads by flipping a coin is 1 upon 2 to the power I, because this flipping of coin is going to kind of, I can say, increase the number of levels. And the next statement which says if each of n items is present in a set with probability p, the expected size of the set is np, and hence we can say that the expected space usage of a skip list with n items is order n. So space usage, which was kind of troubling us in a way, the expected space usage is not more than order n, and your kind of I can say the operation complexity or the search and update times as expected are coming as order log n also. So here we can say that this skip list is actually something which is kind of a perfect or close to perfect data structure for various scenarios in which your binary search trees are skewed. Then we can use your skip list, or we can also use this skip list for the implementation of dictionaries and so on and so forth, and other applications will also follow. So in this lecture we tried to understand the 3 operations which are search, insertion and deletion in the skip list, and we have also seen kind of I can say some amount of analysis regarding the time complexity and also the space usage of this skip list. I hope you have enjoyed the lecture. I will see you in the next lecture. Till then, take care. Goodbye.